All right, so this is the second type of problem I'm doing with the topic on solving an inequality. So we just did the first one, and here this one's a little bit harder just because it has a negative sign. So let's go ahead and check this out. Same steps, 4 steps to do this, solving an inequality. An inequality means it has a greater than or a less than sign. So the first thing you want to do is to set the inequality less than or greater than 0. So right now it's greater than 3. I'm going to bring this over to the other side. So when I do that, I'm going to subtract 3 on both sides. And honestly, I don't like the negative sign here because I know I'm going to factor this eventually in step 2. So because I don't like a negative sign, I'm going to multiply or divide, however you want to think of it, by a -1. So when I multiply or divide everything by -1, I'm going to get x squared minus 4x plus 3. It changes the sign. And because I divided or multiplied by -1, I switch that sign. So remember, an inequality sign, if you ever divide or multiply by a negative, you need to switch the sign. And 0 divided by -1 is still 0. So here's my step 1. My step 1 is I set the inequality greater than or less than 0. Now the next step is to temporarily make this an equation and then solve for x. So if I made this an equation, I have x squared minus 4x plus 3 is equal to 0. And if you are at this point, you should see that this is familiar. This is a quadratic equation, and we know how to solve quadratic equations. So to solve a quadratic equation, we factor it. So if you factor it, you end up getting this. Oops, this is a 1. And then you use a zero product property. So I'm going through this kind of fast, assuming that you guys know how to do this at this point. So here I have my answers 3 and 1. So x is equal to 3 and 1. These are what I called critical numbers. These are not your answer. These numbers, 3 and 1, are the numbers that will make this equation, this inequality, equal to 0. So if I plug 3 and 1 into this inequality, it'll equal to 0. But notice, we're not interested in when it equals to 0. We want to know when will it be less than 0. So since at 1 and 3 is going to be equal to 0, what happens around those numbers? What happens to the numbers that are in between 1 and 3? So here in step 3, I'm going to put these critical numbers on a number line and test points around it to find out whether these numbers will result in a positive or a negative answer. I know I'm going fast, but I figured you guys can pause the video as you go along. So x equals to 1 and 3. I'm going to put this on the number line, and make sure when you put it in the number line, you write it in numerical order. The smallest first, and then the bigger one to the right. So at 1 and 3, at x equals to 1 and x equals to 3, I know that my function will equal to 0. So what happens around it? What happens if what happens for numbers less than 1, numbers between 1 and 3, and what happens after 3? It's not going to be equal to 0, so it's either going to be less than or greater than 0. So I'm going to test points. So that's a key thing in step 3. So let's test a point. Let's plug in a point less than 1 into the inequality and see if we get a positive or a negative answer. So work smarter, not harder. What's a number less than 1? You could put 0, -1, -2. You know what? The easiest number is 0. If I plug 0 into this function, and it could be either this one or this one, because this is a factor form. If I plug 0 in here, do I get a positive or a negative number? If I plug 0, I get 0 minus 0 plus 3. That's going to be a positive answer. So if I plug a -1 in here, I'm also going to get a positive. Anything less than 1 will always give me a positive. What's a number between 1 and 3? So say the number 2. So if I plug 2 in here, I get 2 minus 3 is -1. 2 minus 1 is a positive 1. Well, a negative times a positive will give me a negative. Last but not least, what's a number bigger than 3 that I could test? So I could plug in 4, 5, 6, 100. It doesn't matter. I'm just going to use the number 4. If I plug 4 in here, I get 4 minus 3 is 1. 4 minus 1 is 3. So a positive times a positive will give me a positive. So again, if you plug the number 10 or 1,000 or 100, anything bigger than 3, if you plug in here, it'll always be positive. So this number line tells me what kind of answers I'll get when I plug it into this inequality. So anything less than 1, I'll get positive answers. Anything between 1 and 3, I'll get negative. Anything bigger than 3, I'll get positive answers. So the last step is to answer the question. Well, the question is, what will make this inequality less than 0? In other words, I want the negative answers. What will make this less than 0? What will make it negative? So here in my number line, the parts that will make it negative is everything between 1 and 3. So when it tells me to graph my answer therefore is everything between 1 and 3 will make this inequality a negative. And it does not include 1 and 3 since there's no equal sign. If there was an equal sign here, it'll be less than or equal to 0, then I would put a solid dot on 1 and 3. But since it's strictly less than, there's no equal sign, I'm going to do an open circle on 1 and an open circle on 3 to signify that the 1 and 3 are not included in the answers. Because if I plug 1 and 3 in, I'm going to get equals to 0, which is not what I want.